Hello everyone, it's Wilson here. Today I want to talk about how to find the length of this curve, which is a really basic simple curve, y equals x squared. And we want to find the length from x equals -1 to x equals 2. And so you can see that this is a simple curve. This looks like a really simple problem, but when you actually sit down and do the calculation, you realize that it involves a lot of calculation. It involves integration techniques, multiple integration techniques that you need to use. Okay, so you will see when we actually do the problem. So let's get started. So first, we want to use the outline formula to help us find the length of the curve, which will require us to use the derivative for this function. So what we want to do is that first we got to take the derivative of the y equals x squared, right? So let's do that. So what do we get here? So dy, right? dy over dx. That's what we want, right? We got to take the derivative, which will just give us 2x. Okay, so just 2x. It's actually quite simple. Now we are going to set up the integral. So when we set up the integral, we are going to get L equals the integral from -1 to 2, as you can see here, because we are going from -1 to 2. And then you have the square root. Okay, so the L stands for the odd length, right? So we have what do we get here? We are going to get 1 plus dy over dx, and then quantity square, and then all that, right? When you sum them up, you are going to get it under the square root. So you get the dx right here. So that's the integral. So now we are going to set up the integral like this. So we have the integral from -1 to 2, and then we have the 1 plus. Now, what is the dy dx? It's just 2x, right? So you are going to put it in the square. So that's what you have here. So 2x square. And then we get the dx right here. Okay. And then now you are just going to simplify this, and then we will be getting, so -1 to 2, and then you have 1 plus what, 4x squared, and then the dx. Okay, so far so good. Now we are going to look at how we can integrate this integral here, because eventually after we find the antiderivative, we got to use fundamental theorem of calculus to put this -1 and the 2 into the antiderivative, right? And right now, if you look at this, that's just a single integral here. We have 1 plus 4x squared. So what happened is that if you just look at the form, this tells us that we got to use the trig sub, right? Trigonometric substitution. So how do we do the trig sub? Let's think about this form right here. So first, we can actually factor out the 4, right? Because we may not really want the 4 in front of the x squared. So it will be a good idea to factor out the 4. And then, so we also need to factor out the 4 from the 1. Right, so we do that, then we are going to get -1 to 2, and then you are going to be getting 4 in the front, right? Then you are going to get 1 over 4, because 4 times 1 over 4 gives you the 1, and then plus x squared. Okay. And then now just that. So at this point, we can actually start making the substitution in here, right? We can start making the substitution. So based on the x squared plus 1 over 4, that tells us that we're going to make the substitution, which is to use the x equals 1/2 tangent theta. Okay, so we got to use that. And then from there, we also need to find the derivative of x, right? Or with respect to theta. So we got to find the dx. So we are going to get dx is equal to 1 over 2 secant squared theta, d theta. Okay. And also, it would be a good idea to actually rewrite this one so that it will be 2x is equal to tangent theta, because we may need that information later on, right? Depending on the situation. We may or may not need that information. Okay, so we are ready to actually do the substitution, but then also we need to worry about the limits of integration, right? So we getting the limits of integration, we also should be switching the limits, or you can just wait until you switch back to x to use those limits, but we can just switch the limits right now. Or we can just ignore the limits. Okay, so actually let's just ignore them right now because I may run out of space if I try to switch the limits right now. So okay, so what do? We can start making the substitution here. Now pretend that the limits are not there. We are just going to focus on the indefinite integral here. So now from this square root of 4, you can actually take it outside. So you actually get a 2 on the outside, right? And then now inside the square root, we are going to be getting the 1 over 4, right? 1 over 4. And then plus. Now the x squared is what? So you're squaring this 1/2 tangent theta. So now if you square that, okay, so you square the 1 over 4, then you are going to get 1 over 4. And then you also need to square the tangent, right? Because you're squaring the whole thing. So you are going to get tangent square theta. Okay, but there was one thing that's really important is that there was a dx right there, right? So you don't forget that there was a dx, so you still got to put that there. So we are going to be getting 1 over 2. So 1 over 2, and then you have the secant square theta d theta. Okay, so now the integral becomes this one, except that I omitted the limits of integration right now. And then now from there, you can actually see that we can cancel out the 2 and then the 1/2 right here because we don't need them. And then now what do we get? So continue, we have the integral, okay? We can factor out the 1 over 4. So we are going to be getting 1 over 4, and then we get 1 plus tangent square theta. Okay, so far so good. And then we also have this secant square theta, right? So you're just going to get secant square theta d theta right here. Okay. Now what? Now, this 1/4 does not matter. You can take it outside the square root, which will become a 1/2. And then now that 1 plus tangent square will give you a, what is that? That's going to be a secant square, right? Secant square theta. But don't forget that that's also inside the square root. So you are going to have the square root and the square cancel out, right? So that will actually give you secant cube, as you can see here. So the next integral will actually turn into, okay, so again, this will come out as 1/2, right? So you get 1/2 integral, okay? And then this one, the green one, becomes secant, just secant theta, right? Because of the square root and the square. So you're just going to get 3 copies of the secants right here. So you get secant cube theta d theta here. Is that okay so far? Now you may say, what about this thing right now? This thing requires us to use integration by parts. Okay, so we got to use integration by parts for this one. So what happened is that you got to break it up. Okay. So what happened is that we got to break up the function. Okay, so we have 1 over 2, and then you are going to get secant theta, right? And then you break it up as 2 functions. One of them, the other one is going to be secant square theta d theta right here. Okay. Yeah, so we have a product, right? One is secant theta, the other one is secant square theta d theta. And then now let's set up the integration by parts table here. Okay, so what happens is that we have plus, minus, and then d, and then I, and then also this one right here. Okay, so now so I think we need more space. So I'm just going to put the d here, and then we put the I here. Yeah, so we have plus, and then now all we need to do is to put the secant theta right here. Okay, and then what about the other one? The other one is going to be just the blue writing here, right? This is the one that we can integrate. And usually we are going to just omit the d data right here. And so now go down from here, then you are going to get what? We are going to get minus. Take the derivative of secant data, then we are going to be getting secant data, tangent data. Now, what about the antiderivative of secant square? We are going to just get tangent data here. Okay, so we are actually ready. We are actually ready to start writing down the the results for integration by parts. And by the way, we also need to multiply all this stuff together to get whatever that we have here, right? So you are going to be getting negative integral, right? Because that's coming from this minus sign here. Secant data times tangent times tangent. So you're going to get secant data and then tangent square d data here. Yeah, so that's the integral that we are getting. But then because I need to keep track of the space, so I'm just going to put it down here. Okay, so what happened is that this stuff right here is also the stuff that need to go here. Right? So just fill the spot right here. Okay, now this integral actually becomes this one, except that I ignore the 1/2 right now. Okay, so if I claim this integral, so if I give this integral a name, so let's call it W because it stands for Wilson, right? So we are going to have what? We are going to have W, okay? And it's equal to what? Now let's write down the integration by parts stuff right here. We have secant data times tangent data. So we are going to get that. So secant data and then tangent data. So far, so good. And then now what's next? The next step is to put down this integral right here. So we have minus this integral. Okay, so we can actually rewrite this tangent square data, right? So we can actually rewrite this. So we can rewrite this as secant square data minus 1, okay? So what we can do is that we can distribute the secant data to the two terms inside the parentheses. So that will actually becomes secant data, tangent data, okay? Now, this part needs to be done really carefully, okay? So what happened is that you are going to be getting minus, okay? And then the integral. Okay, so now if we distribute the secant data to the secant square, so we are going to get the secant cube data, d data, okay? And then now the second term, we actually can put it as a separate integral. So there was a minus sign here, there was a minus sign here, we actually get the plus, the integral of just secant data. Now, do you see what happens right here? This thing is actually just what? This thing is actually just W. This thing is W. So if we add this thing to the other side, right? Because we are getting back the original integral, so it's not going to get us anywhere. So if we put this on this side, we can actually solve for W, which is something that we are trying to determine here. So if we add this one to this side, you are going to get 2W. Then you get secant data, tangent data, and then plus. Now we can integrate this one really easily. If you remember, it's antiderivative, right? So otherwise you will have to do more integration. So we get secant data plus tangent data. Yeah, so the antiderivative of secant is ln of absolute value of secant data plus tangent data. Is that okay so far? Now, we are solving for w, right? We are solving for w, so we can just divide both sides by 2. So we are going to get 1/2 secant theta tangent, and then plus 1/2 ln of secant theta, and then plus tangent theta here. So we got w. So this is w, but then you know that we are still going to have to multiply by another 1/2 right here. Okay, so we still need to multiply by another 1/2 here. But that's not finished yet. That's not finished yet because we need what? What do we need here? What we need is that what we need is that we are going to have to, well, let me just multiply by the 1/2 first. So just do it step by step. Plus 1/4 ln of secant theta, and then plus tangent theta. Okay, and basically when we get to this step, that will give us this thing. Okay, and because I'm running out of space, so I'm just going to remove a big portion of the stuff that we don't need. And actually, if you want to see that, I have another video for an integration of just this integral here. So right now, I'm just going to erase all the work so that I can free up my space that I have right here. Okay, so let me see all this stuff, right? So let me just remove them. Then we don't need that here. And so basically that's equal to this one, right? So I'm just going to take that result right here. I'm just going to take that result right here. So this is the expression that we want. And then, yeah, so a lot of work that was being skipped right here. So you got to do integration by parts. Okay. Okay, now, what's next? Going back to doing the tricks out, right? We're done. All we need to do right now is to switch back to the original variable x, or we can find the limits right now and then plug them in. It's up to you. So I'm just going to switch back. So how do we switch back? We can draw a triangle based on this one. So let's just draw a triangle based on this one. Okay. So now the data is the one that we are looking at right here. Okay, so now it says tangent theta is equal to 2x. Well, we can put it over 1, right? So that means we can do opposite over the adjacent. And then the hypotenuse, based on the Pythagorean theorem, we are going to get 4x squared plus 1, right? You square the opposite, square the adjacent, you add them together, and then put them inside the square root. So now you have the triangle here. So continuing from here, right? Continuing your work from this step to here, then what do we get? We are going to be getting, 1/4. Now secant theta is what? Just the hypotenuse over the adjacent. So you get 4x squared plus 1. Okay, and then tangent is actually just 2x, right? So we just get the 2x right here. And then now what's next? Plus 1/4 ln of, now the secant theta, we already figured it out, which is this expression right here. So just copy. And then plus the 2x. And so basically that's the antiderivative for this square root of 1 plus 4x squared right here. Okay. Now, going back to the definite integral, we have negative 1 to 2, right, of this integral, 1 plus 4x squared dx. And that's really just evaluating this expression right here at 2 and then also at negative 1, and then you subtract them. So you are going to be getting, let's just start canceling some stuff right here. The 2 and that 1 over 4 will get canceled. So you are just going to be getting 1 over 2x square root of 4x squared plus 1, and then plus 1 over 4 ln of the square root of 4x squared plus 1, and then plus 2x. And then you evaluate it from negative 1 to 2. So now, what do? We are going to start plugging the 2 in there, right? So if you plug the 2 in here, then you're going to get 1 half times 2, you get 1. Plug the 2 in here, you get 2 squared, which is 4. 4 times 4 is 16, plus 1 is 17. So you're going to get 17. Well, actually, it will be the square root of 17. And then plus 1 over 4. Now, same thing here. We did the calculation already, so we know that it's going to be ln of absolute value or square root of 17. And then plus, now if you plug the 2 in here, you're going to get 4. That okay so far? And then now, next step is to subtract. This time we are going to plug the negative 1 in there. So 1 half times negative 1, we get negative 1 half. And then if you plug the negative 1 in there, square, you get positive 1. So you get 4 plus 1. So you get square root of 5. And then plus 1 over 4 ln of this one, we already did the calculation, is square root of 5 minus, why minus? Because you plug the negative 1 in here, it becomes minus 2. So you get minus 2. Okay, and then all we need to do is to just remove all the brackets, and then we have the final answer, right? So you are just going to be getting the square root of 17 plus 1 over 4 ln of square root of 17 plus 4. We already know that when we add two positive numbers together, we are going to get a positive number, so we don't need the absolute value anymore. And then I'll just keep going, right? So negative gives you positive square root of 5 over 2. And then now distribute the minus sign with this expression right here. Gives you negative 1 over 4 times ln of, well, we don't need the absolute value anymore because square root of 5 is about 2.2. So this is positive. So we can just use parentheses. And then that's your final answer. It's multiple values all added together, right? So as you can see here. Yeah, see that this problem requires a lot of work, as you can see, even though we have a simple curve right here. It's really because of the square root. And so first we started with the trig sub, and then we realized that we get a trig integral with odd power for the secant. And so we cannot really just do a u sub. We have to do integration by parts. And then I actually showed the integration by parts, but I erased them because I ran out of space. But now you can actually watch the other video for the details if you want that again, right? I actually also show it in this video. And then we got the result. And after we get all this result right here, we can go back to the original variable. And then from there, we use fundamental theorem calculus to plug in our limits of integration. And then we get the final answer. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video. I will see you next time.